Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge. Maximum number of vowels in a substring of given length. So let us first read this question, then about the constraint, and then finally the coding part for the same. And yeah, before that we need to check upon the examples which are given to us so that we can get an observation or we can just check that how we are required to do this question. So let us go ahead. So here, let's first read this question. So given a string s and an integer k, return the maximum number of vowel letters in any substring of s with length k. So basically this k which is being given to us, we are required to get the substring of this much length and need to check that at any point are we able to get a count of vowels which is basically greater than what we have till now. And at the end, whatever would be the greatest count that we are required to return as our answer. See, at max it could be the k itself or it could be 0 if there are no vowels. So this is what we are required to do here. So here comes the part for the constraint. So here the constraint, we can clearly see that it is 10 raised to the power 5. So that simply means we are required to do an order of n or order of n log n solution. N square won't work here. And another constraint is given that all are lowercase English letters. So in that context, we are not required to convert any uppercase to lowercase or anything like that for comparison. And k can go at max till the length of this particular string. If we are there could be a test case where we are required to check that in this whole length how many vowels are there at as a whole means as this particular string as a whole substring. So these were pretty much about the constraint. Now comes the part for the coding of the same. So before going ahead with the coding part, let us take this example in this or this. So let me show you that how I would be required to do so. One minute. So here, for the first example which was there where k is equal to 3. So here, af- if we slide a window of k length that is 3, so ABC has 0 vowels, then BCI has 1 vowel, then CII has 2 vowels, then triple I all three are itself 3 vowels, then double ID is having 2 vowels, and then DEF have 0 vowels. So like this, if you slide a window of 3 length, then each we can check that how many vowels are there. So basically, so as we slide a window of length k, we eliminate previous vowel count and add up the new vowel count if that exists, and parallelly uh, will simply maintain a maximum vowel count. So like this, at the end, we are required to return that maximum vowel count which is there as our answer. So this is what we are required to do in this particular question. So the thing is, just take the k length window which is there, move ahead with that particular k length window, and at that moment only we are required to eliminate the uh, the previous element which was just previous to the same of that particular window, so that it is simply like we are sliding the window ahead and eliminating whatever count was there. So let me show you that how we are required to do this question, and let us go ahead for the same. So here let me show you directly the coding part for the same. So here we are taking unordered set. We can even take a vector, and in that vector how we can do is like we can take directly initialize that vector with 26, and wherever a e i o u exists there we can directly mark them as 1 and others should be 0. So like that way also we can take. Another way is which comes to our mind straightforward is taking in another set, so that in order of 1 we can directly do a check that yeah these characters are present or not. If these characters are present then surely they are vowel, and because of that only we'll increase our count. So that's the thing. So first thing we'll do is we'll run our loop from I to k so that we can check that in the first k elements which are k characters which are there, so are we able to find the number of vowels there. So whatever number of vowels we will be figuring out, that we will be adding up in this count. And then we will be adding simply initializing our answer with that particular count, and then after that we'll run from our key I to k to s dot length. So here what we are required to do is we are required to just slide our window in such a manner that we are eliminating a previous uh, character which was there. So here we are taking the present one and just eliminating the count of the previous one. You see what we are doing here is simply if a window is hmm, so here what we are doing is we are just taking a window of ABC, and then when we slide ahead BCI, so we are just eliminating this particular. Basically the thing which we are doing here I minus K, that simply eliminate because I would be at this moment, right? So here, when I is at this moment and I is basically here equal to k, so that will eliminate I equals to 0. So that's why a would be directly eliminated, and that is what we are doing here. And then at that moment only we'll figure out that what is the maximum till now. If whatever answer was stored till now, that is the maximum, or whatever count we are having, that is the maximum. So this is what we will be keeping parallelly side by side in this, and then at the end we will be returning this answer. So this was all for this, and now comes the part that what is the time complexity and space complexity. So here this unordered set which is there, it is just having order 26 space, which is in itself a constant space. So that's why our space complexity is order of 1, and the time complexity here is order of n, and order of n is simply the length of the string which will be given to us. So this was all for this particular question. If there's any doubt, you could comment it down. So yeah, this was all. Thank you.